Hi, in this video we're going to talk about the quadratic formula and how we can solve a quadratic using it. So first off, the quadratic formula is x is equal to opposite b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And the reason I have it broken up like this and not put into one fraction is that it's really interesting to be able to see what the quadratic formula is giving us in terms of the parabola. So I have an axis of symmetry in this first part, opposite b over 2a, which also is the h, or the x-coordinate of the vertex. And then the second part allows us to know the distance the roots are from the axis of symmetry, which is really helpful in understanding the nature of the roots, and we'll get more into that in a minute. And then we have what's under the radical here, b squared minus 4ac, is the discriminant. So why is that a unique thing? It's because the discriminant tells us a couple of things. The discriminant, when it is less than 0, I have two imaginary solutions. And so you think about it, if under the radical is negative, then I have unreal solutions or imaginary solutions. And then if it's equal to 0, 0 divided by 2a is just 0, so that gives me just the axis of symmetry as the roots, which implies that one real double. And then if it's greater than 0, well, then that simplifies down into two real roots. So the discriminant helps us to determine the nature of our roots. So let's look at an example of how to solve using quadratic formula. So x squared minus 6x equals 4. Well, first off, in order to solve a quadratic, we understand that the solutions are the x-intercepts. And so to find the x-intercepts first, that's when y is equal to 0. So we need to go ahead and set our equations equals to 0, which I just did by moving the 4 over. Then I'm going to label the coefficients that I have. So an a coefficient of 1, a b coefficient of -6, and then a c coefficient of -4. And then I'm going to simply substitute these values into the formula. And so opposite b would give me a positive 6 over 2 times a, which is just 1, plus or minus the square root of b squared minus 4a, which in this case is 1, c is -4, all over 2a. And so then if I simplify this further, I get a 6 over 2 plus or minus 36 minus a -16, which when we see this, minus a -16 is just like adding 16 all over 2. And so then this simplifies 6 over 2 to 3 plus or minus 36 plus 16 gives me a square root of 52 over 2. Well, then we can simplify that 52 into 4 and 13. So then the square root of 4 would be 2, so 2 radical 13 over 2. Well, then these 2 and 2 simplify to 1, and that gives us the solution 3 plus or minus root 13, which gives me the solutions. And it's important to remember in this case, that's a in this case, it gives us two real roots. One, we know the nature of the roots because the discriminant was greater than 0. But also we know that it's two of those roots because we do expect two solutions from a quadratic, and that plus or minus allows us, it gives us those two. So 3 plus root 13 is one solution, and 3 minus root 13 would be one. And so it's really useful to use quadratic formula when all other means are exhausted or you're unable. So if something's not factorable or I can't take the square root, the next step in solving would to be used the quadratic formula. Thanks for watching.